Back in 2017, a paper dropped with a title that sounded almost deceptively simple: Attention is All You Need. But this paper didn't just introduce some new little idea. No, it lit the fuse for the absolute explosion in AI that we're all living through right now. I'm talking about everything from ChatGPT to, well, to everything else. So let's break down what was inside that paper that literally changed the world. Okay, so to really get why this paper was such a revolution, we have to start with the fundamental problem it solved. For years, this was the question that kept AI researchers up at night. How do you actually teach a machine to understand language? I mean, really grasp the meaning of a sentence if it's forced to look at it one tiny piece at a time? You see, before 2017, pretty much all the top models for language worked sequentially. I want you to imagine trying to read an amazing novel, but you can only do it by looking through a tiny peephole, seeing just one single word at a time. To make any sense of what's happening, you'd have to perfectly remember every single word that came before. That's exactly the challenge AI was facing. The go-to technology for this was something called a recurrent neural network, or an RNN. The way it worked was, well, just like it sounds. The model reads a word, it updates its internal memory of what's going on, then it reads the next word, updates its memory again, and just keeps doing that step by step, hoping to carry the context forward. But this whole one word at a time thing had two massive, and I mean massive, drawbacks. First, it was painfully slow. Because everything had to happen in order, you couldn't process different parts of a sentence at the same time. You couldn't parallelize the work, and that was a huge bottleneck. And second, these models were forgetful. By the time they got to the end of a long paragraph, they'd often forgotten what the first sentence was even about. So the researchers behind this paper proposed a pretty radical new idea. They asked, what if, instead of looking through that tiny peephole, the model could just see the entire sentence all at once? What if it could instantly weigh the relationships between every single word to figure out which ones are most important to each other? They called this idea attention. And the core innovation that makes this possible is called self-attention. Forget that linear chain we talked about. I want you to picture a web of connections. So in a sentence like, the robot picked up the ball because it was heavy, self-attention lets the model instantly connect the word it all the way back to ball, no matter how far apart they are. It's a total game changer. So how does this magic actually work? Well, you can think of it as a simple three-step process. For any given word, like it, the model first creates a query. This is basically the model just asking a question, like, hey, what does this word mean in this specific context? Okay, next step. It takes that query and it compares it against every other word in the sentence. Each of those words has something called a key. Think of it like a label that describes its role or its essence. The model is checking the query for it against the key for robot, the key for ball, and so on, looking for the best possible match. And finally, once it finds the best matched keys, in our case, the key for ball would light right up. It pulls forward that word's value, which is its actual meaning. Now, here's the cool part. It does this query, key, and value dance for every word at the same time. So the model isn't just reading, it's building this rich, interconnected map of meaning for the whole sentence all at once. Building on this incredibly powerful idea, the researchers created a completely new architecture. They called it the transformer. And its design was revolutionary because it just flat out threw away the old, slow, sequential structure and relied entirely on this new attention mechanism. At a high level, the transformer uses a proven encoder-decoder structure, which is really common for tasks like translation. The encoder's job is to read and really understand the input sentence, say in English. And the decoder's job is to take that rich understanding and generate the output sentence in another language, like German. And both the encoder and decoder are built from a stack of 6 identical layers. And if you were to crack open any one of those 6 layers, you'd find they're all made of the same 2 key components. First, there's that self-attention mechanism we just talked about, which is busy finding all the relationships between words. And second, there's a pretty simple feed-forward network that just processes the output from that attention layer. These two parts work together, layer by layer, to refine the model's understanding. But they didn't stop there. This is where it gets really clever. Instead of running this attention process just once, they did it multiple times in parallel. They called it multi-head attention, using 8 heads at the same time. Think of it like having 8 different experts all reading the same sentence. One expert might be focused on grammar, another on the actual meaning, and a third on the long-range context. By combining what all these experts find, the model gets a much richer and more nuanced understanding of the sentence.
Okay, this all sounds fantastic in theory, right? A faster, smarter architecture. But did it actually work? Well, the researchers put the transformer up against one of the toughest challenges in AI, machine translation.
The results were nothing short of a breakthrough. On a standard industry benchmark for translating English to German, the transformer achieved a new state-of-the-art BLEU score. That's just a common way to measure translation quality, of 28.4. Now, that score of 28.4 might not sound like a lot, but here's the crucial point. It beat the previous best models by over 2 full BLEU points. You have to understand, in the world of machine translation, an improvement of even 0.1 is a big deal. An improvement of 2.0 was, well, it was unheard of. It just blew everything else out of the water. And it wasn't just better, it was dramatically faster to train. And the reason is actually pretty simple. For an old recurrent model, if a sentence was twice as long, it took twice as long to process. The work grew linearly. But with self-attention, all the connections are made at once. The pass between any 2 words is always just one step. This unlocked massive parallelization, and it slashed training times from weeks down to days. So let's zoom out for a second and look at the big picture here. The transformer wasn't just a slightly better model. It was an entirely new blueprint for how to build AI. It was a fundamental paradigm shift in how we think about teaching machines to understand language. I actually want to read this quote directly from the paper's abstract because it just captures the spirit of it perfectly. They wrote that they propose a new simple network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence and convolutions entirely. They didn't just improve the old way of doing things, they threw it out and started over with a simpler, much more powerful idea. And that, right there, brings us to today. You know the T in GPT, the model that powers ChatGPT? Yep, it stands for Transformer. BERT, Lambda, pretty much every single large language model that has made headlines since 2017 is built on the foundation laid out in this one single paper. This was the architecture that unlocks the entire generative AI revolution. You know, the paper's title was such a bold claim, and it turned out to be remarkably true. By focusing on this one powerful mechanism, researchers unlocked a whole new era of what's possible. Which leaves us with a really fascinating question to think about. If attention was all we needed to get here, what's the next simple, elegant idea that's going to unlock the future?